Hello, we are MediHealth Tracker, a medical document phone application. Our group members are Holly Smith, Naman Chang, Ramin Masood, and Perna Hawk. Our capstone advisor is Dr. Hannah Godrich. We are group number S2004. Meet the MediHealth Tracker team. Holly Smith is one of our back-end developers. Naman Chang is one of our front-end developers. Ramin Masood is another back-end developer. Perna Hawk is another front-end developer. A common problem that people face with their medical records is that it is hard to keep track of all your documents. It can be difficult to access physical medical records whenever you need them. It is easy to lose physical documents when you get home from a doctor's appointment. Another problem is accessing information about previous doctor's appointments. It is important to know the history of each medical appointment so that in case of an emergency, you have all your history. There can be issues if people switch between doctors as well. You need to have all documents transferred from your old doctor to your new doctor, and things could be lost in the process. We have a proposed solution to many of these problems. Our application allows users to take control of their health information by giving them direct access to their personal medical documents and general information. We have an application to help you scan your medical documents and keep them organized. Our application also gives you the ability to manually enter information that you do not have a physical document for. So, why us? Security. This application provides security features. Any person that would like to access the application needs to sign in. There is a sign-in so that each user's data is secure. There are also options of dual authentication methods such as send an email confirmation, send an SMS confirmation, or confirm with a fingerprint scan if applicable. HIPAA. Our application follows the guidelines of the Health Insurance Portability and Accountability Act. The security rule requires covered entities to maintain reasonable and appropriate administrative, technical, and physical safeguards for protecting electronic protected health information. Specifically covered entities must 1. Ensure the confidentiality, integrity, and availability of all electronic protected health information they create, receive, maintain, or transmit. 2. Identify and protect against reasonably anticipated threats to the security or integrity of the information. 3. Protect against reasonably anticipated impermissible uses or disclosures. And 4. Ensure compliance by their workforce. Centralization. Our application provides a central place to keep all of your medical records. Common medical applications only keep records for one specific doctor office. At MediHealth Tracker, we are providing you a platform to keep your medical records for all your doctor's offices in one place. Organization. All of your records can be organized by category of the type of document it is. Your files will be listed in alphabetical order based on what tag you give them.
So let's dive into the scope of MediHealth Tracker. There are many elements that we discussed as a group that we wanted to include within our app. We decided on the most important goals we wanted to meet and went from there. First and foremost, our focus was to create a functional mobile application that runs on both Android and iOS. A mobile application will allow users to have easy access to all their medical information at a touch of a button. Since medical information is so sensitive, we understand that we would need a secure and trustworthy application so users would feel comfortable logging in their information. In order for this to occur, we set up an authentication system that secures sensitive info. We use FHIR-based authentication. I will discuss more details about the security in the next slide, as this is an important element of our application. There are many features that we included within our app. There are manually inputted features like medications, immunizations, allergies, doctors, insurance, and reminders. We felt like each of these features held their own value in our application. Perna will later discuss more on this topic. Two other features that we felt were necessary for the organization of MetaHealth Tracker are uploading/storing documents and adding appointments to your calendar. So along with our scope of our application, I wanted to discuss a little bit about the frameworks we used to create our app and why we chose them. So for front-end development, we chose React Native, and for the back-end development, we used Firebase. React Native allowed for us to create functional and organized pages that you will see during our demos. For the backend, we wanted to use a flexible database that also has built-in authentication. This is where Firebase comes in. Firebase allows us to store data easily. Since a well-secure app is of high need here, I want to further discuss how we implemented a monitored foundation within our app. We understand the sensitivity of the information being stored within our application, so we wanted to use a secure database with the correctly implemented authentication to ensure security. If you look at the bottom picture, you can see a list of emails. These are accounts that signed up for MetaHealth Tracker. If you look to the far right column, it says UID. The great thing about Firebase is when you sign up, each person is given a unique ID. Therefore, the only way to access a user's info is by access to their UID. However, to prevent this from happening, we use security rules that disable access for anyone to read/write to the database. Although we have a good setup, we decided to take it a step further and implement dual authentication to reinforce security. So dual authentication will allow the user to receive a text/or email to confirm user identity. With these security measures, we feel confident that the application is trustworthy and reliable. So for our long-term security, we would use AWS, a cloud computing platform. Due to our time constraints, Firebase served as a prototype for our application. However, to protect and store thousands of users' medical information, AWS proves to be reliable. Our main reasoning for using AWS is its great foundation for HIPAA compliance. Additionally, AWS provides VPN encryption to protect data and disaster recovery in case of any impediment in the system. With AWS's experience with healthcare providers, emphasis on protecting information, and the many services provided, as you can see in the table below, AWS would be a strong and durable platform for MetaHealth Tracker. So let's take a look at the app. The first page is login/signup. The login page allows you to log in with only accounts registered to Firebase. If the user enters the incorrect password or the user does not exist, it will notify the user. The sign-up allows users to sign up with their information. Both features are secured by authentication.
We included a profile page for users where they can input their basic information such as their age, birthday, gender, and phone number, as well as an option to include a profile picture. This feature is important for a family, for example, who may have more than one person using the application to make sure that all of the medications, documents, etc. that are listed are for the correct user and not the wrong account. As you can see in this demo, the user is inputting their information to create their own personal profile, which you can view at the end. As soon as the user is finished inputting their information, their profile is automatically created and brought to the screen. After logging in, users are brought to the home screen, as you can see to the picture on the left. The home screen displays all of the features available for the user to use in a central location. The design is similar to that of the iPhone homepage to bring more organized and simplistic look to the features for the user to click on. Throughout this presentation, we'll be going through some of these features and their importance. Upon clicking the medications icon, a list of medications the user is taking is available along with the name of the medication, the provider or doctor, and the directions on when and how many of each medication to take. Now let's imagine an elderly person or a post-surgery patient who has to take multiple pills a day or different medications. This feature allows a user like them to have scroll view of all the medications they need to take in an organized fashion with specific instruction. This feature can also be useful, for example, to a caregiver who needs to keep track of multiple patients with different medications. The users can manually add new medications with descriptions using the Add Medications button, which then adds it to the list, which you're able to see here in the demo. Viewing files. Users can view their uploaded files using the Files feature and scroll through these files organized by alphabetically ordered tags. Users can also upload their files using their camera to take pictures of the files they want to save onto the application, also including tags to organize it in folders. Our allergies feature allows users to manually input their allergies and include their reaction to these allergies and directions on what to do in case these allergies are triggered in an emergency. Users can also manually input their immunizations to keep track of which vaccine they've received and when they've received it and which doctor. This is very important for when a user has to go from doctor to doctor and wants to keep track of their records, or for example has to present a immunization to, for example, a school in order to attend. This appointment tracker allows users access to a full calendar to help them keep track of past appointments, future appointments, and upcoming events such as surgeries, physical therapy, medication pickups, and etc. We also included a reminders feature. This allows users to input any reminders they want on the app to send them a notification, such as picking up a prescription, upcoming appointments, and etc.
Our next and final feature is the emergency feature. After clicking the red emergency button, a list of medical information is given. It shows the patient's blood type, if he or she is an organ donor, an emergency contact number, and allergies. This just lists some of the medical information that can be shared without revealing information that's too personal. We thought this feature might be helpful in a situation where a patient needs medical attention and holds information that a caregiver or medical professional requires. So personal health records, like our app, have rapidly become renowned for their capabilities to support patient-centered care. They enable patients to access, monitor, record, and update their health information regardless of physical constraints such as time and location. And we see that when patients are involved in their care processes with granted access and control, there are better results in patient satisfaction and improvements in care services and clinical outcomes. So is there a benefit in using medical health applications in the future? Not only do studies show that there is a huge potential of benefits regarding these medical-enabled care systems, both for the patient and care professionals, but there is also a capability to enhance patient adherence to treatment, which also improves the clinical outcomes of chronic diseases. So while there is a growing interest in the mobile health applications, there's little guidance in how mobile health applications should be utilized in order to add these values for the patients. With the advancement of mobile technology, it does increase potential advantages and the value. And while we do acknowledge that there are challenges that exist in discussing this topic, especially regarding healthcare professionals and the healthcare systems, we hope to show you that our app lays the foundation and capabilities of how we can utilize these services to take control of our own medical records, which in return helps us better understand our own health information.
Now here is our cost analysis after doing some research. These values are based on estimations. Assuming the cost of labor for coding is $150 per hour, the cost of labor per month per person would be $26,100. That would mean the initial investment costs would come to $417,600. Then after deployment, assuming we host 5,000 users on our application, the annual cost will consist of AWS costs and maintenance costs. That brings our annual cost to $62,000 per year. If we charge $60 for a yearly membership we would receive an income of $300,000, and that would give us a net profit of $238,000, which is 79% of our income. It would take about 1.75 years to get our return on investment.
Unfortunately, there is a reoccurring issue regarding these self-monitoring health applications, and it is low user retention. So with this, some of the long-term improvements that we would like to add to our application in the future includes incorporating more interactive machine learning capabilities. We would like to add like calendar reminders and updates, reminders for your appointments. And this is so that the user can interact more with the application. So things like finding out when is your next appointment, or when was the last doctor's appointment you had. That would be more interactive and help users stay continuing to use our app. Integrating Siri, Alexa, and Google Home would further help with incorporating these functionalities. And of course, keeping an extended history record just to keep track. And then something more in the future, we could start maybe looking into developing services that could also help medical professionals. And that is all. Thank you very much. Do you have any questions?